Hello everyone, my name is Tan Zhen Hong and my student ID is 0386491, and for today my group and I will be presenting about our topic functions. Okay, let's imagine we have an imaginary whiteboard over here which you cannot see. So what is a function and how do you define it? A function is a relation where every input corresponds to only one output. And function can also be denoted as something like this or something like this. Now I'm going to show you four types of function, which are onto, one-to-one, neither onto and one-to-one, and onto and one-to-one. Okay, so as you can see here, my domain is the set that contains A, B, and C, and my codomain is the set that contains X, Y, Z. And in a function, every input from the domain is connected to exactly one output in the codomain. So this is an example of onto. As you can see, all the elements in the codomain is fully used and also completed. However, the object in domain cannot have multiple image, or else it is not considered a function anymore. On the other hand, one-to-one is when each one of the domain element has their own designated element from the codomain. Domain is the object while codomain is the image. So when the object corresponds to the image, it is considered a function. Okay, now this is an example of one-to-one and onto function. Every element in the domain has its own match in the codomain, and all the codomain elements are used. A function that is neither one-to-one nor onto is when a single element in the domain is connected to multiple elements in the codomain. So it's not considered a one-to-one function. Also, since not all the elements in the codomains are used, it's not a onto function either.
We are going to learn about function tests. There are two main tests we use: vertical line test and horizontal line test. Vertical line test to check if it's a function. Horizontal line test to check if it's a one-to-one and can have an inverse. The vertical line test helps us decide whether a graph represents a function. If a vertical line touches the graph at more than one point, that is not a function. Why? Because that means one point input given two and more output, and a function must give only one output for each input. For example, x power 2 plus y power 2 equal to 10. In the graph, it is a circle, but if I input the x, it's get 2 points in the graph, so this is not a function. Once we confirm that something is a function, we can study what type of function it is, specifically whether it's one-to-one or onto. Let's look at a few examples. Example 1. Fx equal x power 2 plus 1. Let's test it with two different inputs. X equal to 2. If x equal negative 2, so both 2 and negative 2 given the same output 5. That means this function is a function, but not one-to-one. In the graph for like this. Example 2. Fx equal to x plus 1. Let me test. If x equal to, you get a 5. If x equal to negative 2, is get -3. Here each input given a different output, so fx equal to x plus 1 is one-to-one function. The horizon line test is used to check if a function is one-to-one. This is important because only one-to-one functions have inverse functions. If a horizon line touches that graph more than once, the function is not one-to-one. For example, fx equal to x power 2. Let's set y equal to 10. That's given x equal positive or negative square 10. 2 x value for 1 y value. That means it fails the horizontal line test. This is a function but not a one-to-one function, and therefore it does have inverse. So we know how to test the formula is the one-to-one function. So how we know the function is one-to-one or onto or both one-to-one and onto. So let's start. For example, fx equal to 2x plus 3 in the graph. For any real number y, we can find a x. So the formula is onto. So what the example is not onto for like this. Fx equal to x power 2 plus 1 in the graph for like this. It is not onto because it cannot get the value in the range in the negative.
Hello, my name is Aiden, and today I'll be explaining the concept of an inverse function. First, let's talk about what a regular function does. A function takes an input value and gives us an output value. For example, we can use fx equals x plus 5. Now, if we use 3 as our input, it will be 3 plus 5 equals 8. 8. So 8 will be our output. So now, let me explain what an inverse function does. An inverse function is essentially reversing the process. So it will be written as f negative 1 x. So its job is to take out the original function and bring us back to the starting input. So in this example, the inverse function will be f negative 1 x equals x minus 5. So if we plug in the 8 as our new input, and now we will get 3 back to our original input. So we're using the output to find back the input and exactly where we started. So we can use some real life example, as in going Taylor's. So how do you go Taylor's? You go from your home, taking the RRT, and taking the bus, and going back to Taylor's. So if we apply the inverse function here, it will be from Taylor's itself from home, we're going from Taylor's to the bus, and to the RT, and to the home. So to summarize, the inverse function is a special function that reverses the effect of the original function. So it helps us go back to where we started, both mathematically and conceptually.
My name is Elvis De Jalpin, and my student ID is 0386498. Today, I'm going to share a real-life example of a function, and that is salary calculations. A function is a rule that connects each input to exactly one output. In real life, One good example is how we calculate a person's salary based on the number of hours worked. Let's say a worker earns RM 15 per hours. Okay, so we can write this as a function fx equals to 15 times x. Here, x represents the number of hours and fx represent the total salary. Okay, let's look at few examples. If the worker works 1 hour, then fx equals to 15 times 1 equals to RM 15. If the workers work for 5 hours, then fx equals to 15 times f times 5 equals to RM 75. Okay, this shows that for each number of hours, there is exactly one salary amount. That's what makes it a function. In conclusion, the salary functions help us understand how work hours and pay are related. A simple but useful example of how functions appear in real life. Thank you. Today, I'm going to talk about a real-life example of a function, and that is temperature conversion. In mathematics, a function is something that takes an input, follows a rules, and gives one output. My example is how we convert Celsius to Fahrenheit. And the formula of this function is fx equals to 9/5x plus 32. Here, x represents temperature in Celsius, and fx represents temperature in Fahrenheit. Okay, let's look at some example. When x equals to 0 degrees Celsius, fx equals to 9/5 times 0 plus 32 equals to 32 Fahrenheit. Another example is when x equals to 20 degrees Celsius, then fx equals to 9/5 times 20 plus 32 equals to 68 Fahrenheit. So if the temperature is 20 degrees Celsius, the function gives an output of 68 Fahrenheit. This shows that each Celsius value has exactly one Fahrenheit value, which makes it a perfect example of mathematical function in real life. Thank you.